Welcome to the world of Infinity Videos.
Purpose. The art of good programming depends upon the discipline of the programmer, no matter what language is being used. The purpose of object-oriented programming, OOP, is to produce well-designed reusable code. In principle, OOP can be done in any language, even assembly. This is because all OO language compilers, assemblers, e.g. C++, ultimately translate the high-level constructs of the language into machine language. Thus there is a mapping from an object-oriented semantics onto the instruction and data arrays that are executable images. Here we will present a design and implementation method for producing OO code in the C language. It turns out that using this methodology will strongly improve your overall program design and implementation, just as you expect when programming in a native OO language like Java or C++. When working in C, however, the discipline applied to producing good designs comes from the programmer and not from the language itself. There are substantial benefits to be gotten from learning how to program OO code in C. The biggest benefit for new students is learning much more about how OO is accomplished in languages like Java. Students tend to take too much for granted when they only learn an OO language and never learn the basis for OO constructs like classes and encapsulation, etc. Learning to write classes and instantiating them in C gives the student a peek under the hood that will help them understand just what the object-oriented facilities are doing. For example, you will see in detail how the new operator works and understand the memory allocation of objects. This insight will help you greatly appreciate just what a language like Java is doing for you, why it is used to code more efficiently, but it will also help you understand many of the pitfalls in languages like Java that a truly knowledgeable programmer should know about. C and C++ are the languages of choice for systems programming. Knowing how to program in these languages is proving to be a real plus in the job market, even when the prospective job does not involve actually programming in those languages. The reason is that technical employers are well aware that candidates who have mastered C have a much deeper understanding of programming in general and are therefore more likely to succeed in a business that is constantly changing. Grounding in programming basics in C positions someone to learn any new language or paradigm that might emerge in the future. This document introduces the student to programming OO using C. While it explains the process and methods, it will not be a substitute for actual practice. Students should exercise their understanding by writing programs that emphasize object-oriented approaches. Some examples will be given below. Abstract data types and encapsulation. The basis of object orientation derives from the concept of an abstract data type, ADT. An ADT is defined as a generally complex data type that can be represented in the computer and the fundamental operations that are defined on that type. A simple example is an integer. An integer is represented by a finite number of bits in a register, of fixed size, say 32 bits wide. It is usually represented using 2's complement format. An integer is a natural number, or its negation, and the operations of arithmetic are defined on the set. Two integers, in two registers, can be added to produce a third integer within the same size limits. Similarly, two integers can be subtracted, one from the other, and so on. We would represent the ADT as integer, all natural numbers between 0 and 2n-1 and the negations of the non-zero values, 1 to 2n-1, where n is the number of bits wide the register is. Operations. Complement, invert all bits. Add, r equals a plus b, c equals carry out. Negate, add, complement, a, 1. Sub, r equals add, a, negate, b. Mul, r equals add a sub b 1 times. Div, r equals sub a sub b 1 times r1 equals b, where r1 is a second result register, the remainder left in b. Others. The arithmetic operations are defined in the mechanics of the arithmetic logic unit, ALU, of the CPU. The above ADT illustrates how there are a small set of primary or atomic operations, complement, add, and then a larger set of operations formed by composing the fundamental ones. All ADTs are defined in this manner. The descriptions of the operations involve algorithms that take data operands and transform them to results. For example, an operation defined on a data type, file would be merge, file A, file B, where a merge algorithm would be specified. Another might be sort, file A, and a composition might be merge, sort A, sort B. Classes in an object-oriented design are fundamentally ADTs. Classes typically contain data elements and a set of functions, methods in Java, that perform operations on the data.